Hi everyone, this is a question from Griffith Quantum Mechanics. It's an infinite square well potential. So here, show that the wave function of a particle in the infinite square well of length a returns to the original form after a quantum revival time t equals to 4m a square by pi h cross, that is psi x comma some time t equal to psi x comma 0 for any state. And the next question is, what is the classical revival time for a particle of energy E bouncing back and forth between the walls? Third is, for what energy the classical time and the quantum revival times are equal. So they want to show the wave function will appear same form at a quantum revival time t equal to 4m a square by pi h cross. So for infinite square well, wave function can be written as psi x comma for time t, you can write it as n equal to 1 to infinity psi x comma 0 for 0 time e raised to minus I e n t by h cross, right? Then for psi x comma capital T, it will be equal to summation n equal to 1 to infinity psi of x comma 0 e raised to minus I e n capital T by h cross. So here for the infinite square well potential, what we have, energy En is given by, for nth state, n square pi square h square by 2m length square. So therefore, we can write psi of x comma capital T. We need only this term, so we will write it as proportional to or some constant a e raised to minus en, that is n square pi square h square by 2m a square into t. We can write it proportional symbol, then we can write e raised to minus n square pi square h square by 2m a square into t is our 4m a square by pi h cross. Then we can cancel m a square 2 will refer to pi and we have h cross. Fine. Okay, so this is equal to e raised to minus 2 pi n square, right? Okay, and we have left one h cross. So here will be one more h cross, 1 by h cross, this h cross. So this will be 1 by h cross. So this h cross and this h cross cancel up. So we will be left with e raised to minus 2 pi n square, right? So this can be written as, here is I is also there, is it? Yeah. So we can write it as cos of 2 pi n square minus negative sign I sine of twice pi n square. So here n square is an integer, right? So something cos of even, or we can write it as cos 2 n square pi, this will be more better, sine twice n square pi. So sine of even function of phi will be 0, right? So these terms is 0, and this one will be cos of even function of pi, even function multiplied by pi will gives you 1, right? So therefore you can say safely that psi of x comma t is equal to summation n equal to 1 to infinity psi of x comma 0, and our this function lead us to 1. So this is equal to psi of x0 as well, right? So therefore we can safely say the psi of x comma t is equal to psi of x0. Now the second question is, what is the classical revival time for a particle E bouncing back and forth between the walls? So our potential suppose 0 in A, this is infinite, fine. So particle goes back and forth, so the total distance will be twice A for particle traveling a distance twice A. So therefore the time, so this is B, is it? So B for time, in order to find the time, classical revival time will be having like time equal to distance, that is twice A by velocity, right? And velocity we can get from v equal to under root 2m by m, right, as equal to half m v square. Okay, so therefore t equal to 2a multiplied by m by twice e, so that can be written as e under root twice m by e. This is our classical revival time. The third question says as, for what energy the two revival times are equal? So they want to say the quantum revival time Tc is equal to T, right? So our Tc is E 2m by E equals to T, that is quantum revival time, is given by 4 m a square by pi h cos. So what we can write, a square cancels, we will be having 2m e, this will be 16 m square a square pi square h cross square, fine. So this 2 and 2, this 16 2 gets cancelled and we will be left with 8, m will get cancelled, right? So we can write E as pi square h card square 8 m a square. So this can be written as 1 by 4 of pi square h card square 2 m a square. So what is this? We have En equal to this, that means E1 is equal to pi square h square square by 2m a square. So this is the same energy, and we can write, we can replace this whole term 1 by 4 into E1. So at energy 1 by 4th of E1, the two times, the classical revival time will be equal to the quantum revival time. Thank you so much.